Hey everyone, so now that we know the basics of probability, we're going to be able to get into how to compute and interpret probabilities when we use the addition rule. So first of all, before we even start talking about the addition rule, we need to talk about something called mutually exclusive events. So when you have two events that have no outcomes in common, think of like they are exclusive. They're exclusive from each other, they're away from each other. So two events that have no outcomes, and we want to make sure it's two events that we're looking at now, not just one, have no outcomes in common. So in common. So we refer to them as mutually exclusive events. So we have mutually exclusive events where we have no outcomes in common at all. So that means that when we're looking at the probability of event A and a probability of event B occurring, so we have the probability when we have our and, something to keep in mind whenever we have and, it means that we want the two events to happen at the same time. So they're happening at the same time. So if we have two events happening at the same time and they're mutually exclusive, well, that just means that we have two events that the probability of both of them happening at the same time is going to be 0. So think about it, for example, if I have the probability that I roll a 6 and roll a 4 at the same time. So roll a 6 and roll a 4 at the same time. Well, I can't roll a 6 and roll a 4 at the same time. It's either I roll a 6 or I roll a 4. So the probability of that happening would be 0 because we would have no overlap. When we're looking at the probability of A or B happening, so think about when I see or in probabilities. For or, we're talking about either event occurring. So A or B occurring, either or both occurring. Not at the same time, but just either or, looking at either or happening. So for example, I would have, so we have either event occurring, when we're looking at both events, either or event. So for example, if I have, once again, the probability of rolling a 6 or a 4, well, the probability of rolling a 6 on a 6-sided die would be 1 out of 6. Then we also have the probability of rolling a 4, which would be 1 out of 6. And either or occurring is that we're going to add the two probabilities together. So when I add the two probabilities together, I get 2/6 or 0.333. That would be the probability that event A, so rolling a 6, or event B, rolling a 4, would occur. So when we look at or, we're looking at either or event occurring. So we would have the probability of A plus the probability of B occurring. We just add the probabilities together. So let's take a look at another example. So we have our rolling 2 dice game that we talked about in our intro activity. So we have all of the italicized are kind of the sums of the 2 dice. Remember, we roll the 2 dice and we figure out what the 2 dice add together to get. So we're going to look at 2 different events and we're going to see if rolling a sum of 5 or rolling 2 even numbers is mutually exclusive or not. Remember, mutually exclusive, you have no outcomes in common, not income. I know I messed up. It's one of those days. So no outcomes in common, so we want to make sure that we have the italicized in here are just the sums. So for example, I'm looking at my 2 different events. So let's say we're looking at rolling the sum of 5. And I want to look at all my possibilities of rolling a sum of 5. Once again, we're trying to see if these 2 events are mutually exclusive, meaning can they happen or do they ever happen at the same time? That's what we're really trying to look at. So if I'm rolling a sum of 5, so my sums of 5 are going to be right in here. We got 4 and 1, 3 and 2, 2 and 3, and 1 and 4. All right. And then if I take a look at also rolling 2 even numbers, so I'm going to roll 2 even numbers, and I'm just going to highlight those in orange. So 2 even numbers, rolling 2 even, we have, let's see, 2 and 2 would give me 4, 4 and 2, 6 and 2, we got 4, 3 is not even, but we got 4 and 2, 4 and 4, 4 and 6, we also have 6 and 2, 6 and 4, and 6 and 6. So looking at those two different possibilities, would we have these events happening at the same time? Do we have any type of overlap? That's really what it's asking. No, we have our yellows and then we have our oranges. So we said these are mutually exclusive because they have no events in common. So we want to make sure that they have no events in common at all. They have no overlapping. Therefore, they are mutually exclusive. One happens, the other happens. There's no overlap happening here. They can't both happen at the same time. So looking at the probability of A, so our probability of event A are rolling a sum. So there are 36 possibilities. So out of the 36 possibilities, we know that there are 1, 2, 3, 4 of which we have of rolling a sum of 5. And then we also have the probability of B happening. So B is all my highlighted orange. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities out of the total of 36. So because these are mutually exclusive, I can then just add the two probabilities to figure out the probability of A or B happening, meaning I roll a sum of 5 or I roll 2 even numbers. Because I'm just going to take my probability of event A, so the probability of rolling a sum of 5 plus the probability of event B happening, so either or happening. I want to make sure it's a combination. I can either roll a sum of 5 or roll 2 even numbers. I'm going to add those two probabilities together. So I'm going to take 4 out of 36 plus my 9 out of 36 possibilities, which gives me 13 out of the 36 possibilities, which gives me 0.361. That's my probability of rolling a sum of 5 or rolling 2 even numbers. All right, so let's go ahead and take a look at a few more examples here. So I want to either roll a sum of 4 and rolling doubles. So we're just going to look and see if these events are mutually exclusive or not. We're not going to find those probabilities. And if they are not, we're going to give an example of where they overlap. So once again, mutually exclusive, there's no overlapping. Not mutually exclusive, they're happening at the same time. Therefore, we have events that are going to be in common. So we're going to actually name an example of where they would overlap. So for example, we have the rolling a sum of 4 and rolling doubles. So if I'm looking at sums of 4 here, I have this one, and this one. So sum of 4 here, here, and here. And rolling doubles. Out of these possibilities, I have a 3 and a 2, 2 and a 2, and a 3 and a 1. Notice rolling a double, rolling a 2 and a 2, and a sum of 4 can happen at the same time. Therefore, these are not mutually exclusive. And I'm just going to write not NE for short. So we have a not mutually exclusive. And an example of this is that you can roll a 2 and a 2 and satisfy both of those events. Because I can roll 2 and 2, it's a sum of 4, and they're doubles. So these are not mutually exclusive. We have some type of overlap. So what I want you to do is go ahead and pause this video. I want you to try B, C, and D. And then go ahead and once you have those, go ahead and play the video to check your answers. All right, so you should have B, C, and D completed. So taking a look at rolling an odd sum and rolling a 3, those are not mutually exclusive because you got multiple overlaps, one of which you can roll a 3 and a 2 and get a sum of 5. You can roll a 3 and a 4 and get a sum of 7, or 3 and a 6 and you get a sum of 9. So all those would be an example that you could put down. You only had to put one, so I just put all of the opportunities that you could. Looking at C, rolling a 4, so rolling a 4 and having a sum of 12, no matter what you roll in the other dice, whenever it's 4, we're never going to have a sum of 12, therefore they are mutually exclusive. When we're rolling an odd number and rolling a sum of 10, looking at all of our odd numbers, we can go through and see if we can ever roll a sum of 10, so 1, 3, once you get to the 5, we have a sum of 10. So when we roll a 5 and a 5, we would have a sum of 10, and we have an odd number that we rolled. So those would be not mutually exclusive because we can roll a 5 and a 5. So how do we find probabilities when they're not mutually exclusive, though? Because here, when they are mutually exclusive, we can just add them together. So what happens if we have some type of overlap? What do we need to do? That's what we're going to talk about next. So taking a look at our next example, we're going to take our dice rolling again, and we're going to take a look at finding the probability of rolling doubles or rolling a sum of 6. So rolling doubles and rolling a sum of 6. So I'm going to go through once again, and I'm going to highlight all of my different areas, all of my different outcomes where I'm rolling doubles. So if I'm rolling doubles, I'm rolling a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, 5 and a 5, 6 and a 6. So I'm getting these values here. And you can just circle them if you want to. Or, no, that's totally fine. And then we're going to take a look at our second event, which is event B, rolling a sum of 6. And I'm just going to highlight this in orange. So we're going to roll a sum of 6. So looking at a sum of 6, here, 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 and here. Notice that we have, when we're going through here, are these events mutually exclusive? Well, no, they're not mutually exclusive because we got this overlap here. We can roll 2 3s and get a 6, so we have some type of overlap. So this is not mutually exclusive. Reason why we're explaining is that we can roll a 3 and a 3. So if I find the probability of event A, so probability of rolling doubles. So if I'm just going to roll a double, I'm just going to count. There's still 36 opportunities. So out of that 36, we have 1, 2, 3, 4, 5, 6 times where I can roll doubles. Okay, 6 different opportunities. Event B is rolling a sum of 6. So looking at a sum of 6, out of the 36 possibilities still, we have 1, 2, 3, 4, 5 of those opportunities that are going to be happening when we're rolling a sum of 6. So the probability of A and B, so remember this is the probability that they occur together. So the fact that we're going to roll doubles and also roll a sum of 6, well, we have one of those opportunities. We have one time where I can roll both and satisfy both of those events. So I have a 1 out of my 36. Remember, this is where the probability that they occur together. So when I'm looking at the probability that the two events are occurring together, well, that's going to be our overlapping piece. So if I take our probability of A or B, just like we were doing with mutually exclusive events, I would just add the two different events together. I'm going to take the probability of A happening plus the probability of B happening. So if I were just to have mutually exclusive, I would take my 6 out of 36 and add my 5 out of 36 to get my mutually exclusive event. So I would take my 6, 1, 2, 3, 4, 5, 6, and I add my 5 together. But notice that we're double counting this overlap here. Here I would have 6 plus 5. I'm double counting this middle piece. If I were to do this by hand and say, okay, what's the probability of A or B happening? So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of those 36 opportunities. So we have to actually, because we're double counting this guy when we're looking at our probability of event A or B happening, I need to make sure that I subtract out my overlap. So I'm going to subtract out my probability of both of them happening. So my 1 out of 36. And so that way I get my 10 out of 36, which is what I counted by hand, which in a decimal is 0.278. So that's kind of what this italicized is. So we have that when we have two events that are not mutually exclusive and we have events that overlap, we can add the two individual probabilities together, but then we're adding them and double counting that overlapping value or that overlapping event twice. So we have to subtract out those overlaps in order to get our true probability, because we want to make sure we only count it once. So this is called the addition rule or the general addition rule, where I can take, and this is going to work for mutually exclusive and not mutually exclusive events, because we know that the probability of A and B happening when we have mutually exclusive would just be 0 anyway. So we're not going to be subtracting out any overlap because they have no events in common. So the general addition rule for this is that if you have event A and B and there's two events resulting in for some chance process, then to find the probability of A or B, we take our probability of A and we add our probability of B happening, and we subtract out the probability of A and B occurring, because we want to make sure we subtract out that overlap. We got to subtract out at least one of them. We're going to count the first one in one of the events, but we're going to subtract it out of the second event. So notice that if you do have mutually exclusive events, probability of A and B is going to be 0, just like we were talking about. So still, if we were to have the probability of A or B happening, we would still just add the probability of A plus the probability of B. Oops. Because we would be subtracting probability of A and B, which is 0, which really doesn't really matter. So it's just something to keep in mind. I would make sure you star this, highlight it, underline it. This is going to be your general addition rule. So sometimes finding the probability of A and B is not very easy. Sometimes so far we've just used common sense. However, there is a mathematical way to find the probability of A and B, which we'll talk about. It's called the general multiplication rule. We'll talk about that here in the next few lessons. But for now, we're just going to use common sense when we're trying to find the probability of A and B. All right, some of you, once again, are familiar with decks of cards. Some of you are not. So I want to go ahead and put pictures of your decks of cards on here. We're going to do some probabilities with mutually exclusive events or not mutually exclusive events and finding those probabilities here in a minute. Remember, there are 52 cards in a deck. There are 4 suits. You have 2 black suits. So you have clubs and spades that are both black. And then you also have hearts and diamonds that are both red. So you have half the deck is black, half the deck is red. So just keep that in mind. So taking a look at our first probability here, we want the probability that we're going to get a red or a queen. So remember, half the deck is red, half the deck is black. We have king through ace on all suits. So when we're looking at the probability that we have a red or a queen, just keep in mind that we're taking a look at our probability that we're going to have a red plus the probability that we're going to have a queen minus the probability that we have a red and a queen. It's the probability that both are occurring. So we need to see if they're mutually exclusive first and then go from there to see if we're going to be subtracting out anything as well. So looking here, we have the probability of our red, because that's our first event, plus the probability that we're going to get a queen, minus the probability, because we have our or, probability that we have a red and a queen. So if I want to look at the probability that we're going to get a red card, so we have out of the 52 decks of, or 52 cards, half are red. So looking at half of the red here, we're going to have 26 because there's 13 cards per suit. If I'm looking at reds and queens, so red and a queen. So here we have in our reds that we just said, the bottom two suits, we have two that are queens. So these two, because we have some overlap, these are not mutually exclusive, meaning that we have two queens that are also red. Remember, this is the probability of both of these occurring. So we have, out of the 52 cards, we have two red queens. So now, when I'm looking at the number of queens that we have, though, we have 4 queens out of the 52. So I had out of these 26, and then we had the 4 queens. Notice we had that overlap there that we have to make sure that we subtract out, because we're double counting both of those 2 queens in both sets, in both events. So when I do so, I get 28 out of 52, which in turn gives me 0.538 as a probability. So what I want you to do is try B through D and go ahead and pause the video, work on it for a few minutes, and then go ahead and press play to check your answers. Alrighty, so now that you've tried the problems, here are the answers. So looking at the probability of ace or a king, we can't draw an ace and a king. So these are mutually exclusive because you're either going to draw an ace or you're going to draw a king. Probability of drawing an ace, there's 4 out of 52. King is the same amount, and there's no overlap, so you subtract out 0. So we have 0.154 as our probability of drawing an ace or a king. Looking at queen or an even number, once again, they're mutually exclusive. If we're looking at all of the even numbers, you had 2s, 4s, 6s, 8s, and 10s, none of which were queens, so therefore those are mutually exclusive. So we take our 4 queens plus our 20 even cards, we get 24 out of the 52, or 0.462 as our probability. Looking at the black cards and an odd number, so we have just our black, so the 26. We have odd numbers. Now, aces are not odds. Aces are just aces. So it'd just be 3, 6, and 9 out of all of these. So 3, 6, 9. Notice we have those overlapping pieces here, where we have 8 overlapping cards. So we have to make sure that we take the black, which is 26 out of the 52, plus the odd cards, which was 16 out of 52, and subtract out the 8 overlapping pieces, and we get 34 out of 52, or 0.654. All right, so the last thing we're going to talk about is when we actually have a two-way table, and we can use this to find probabilities as well. So we have, you were interested in how many students at the school regularly eat breakfast. So we have, do you regularly eat breakfast? And then whether or not they're male or female. And there were 600 students that participated in at the school. So it says if we randomly select a person at random from this sample, what is the probability that a student is female? So we're talking about only one variable here. We're just looking at the females. So out of the total amount of people, so out of the total 600 people, I want to figure out how many were female. Well, we're just looking at this female piece. So 278 were female. We take 278 divided by 600, and we get 0.463. All right, looking at B, we want the probability that the student is someone who eats breakfast regularly. Therefore, we're only looking at those that eat breakfast regularly. So we're only looking at one variable again, just like we did in the basic probability. So we're looking at the total out of the 600 individuals. There were 300 that said that they eat breakfast regularly, which works out with a nice perfect 0.5. All right, taking a look at C, we have a female and eats breakfast regularly. So we're looking at two different variables, and we're looking at the overlapping because we're looking at the and, so them happening together. So we want a female and eats breakfast regularly. Can't speak. And we have 110 females that eat breakfast regularly. And we have 110 out of the total of 600. So take 110 out of the total of 600 and we 0.183. So now we have our or. So the probability of either or happening. So whenever we see or, we should know that we want either or, and then we have to see if they're mutually exclusive so we can subtract out the females that eat breakfast regularly. So we have our probability of females. So the probability that they're female plus the probability that they, I'm going to say eat, minus the probability they're female and eat breakfast regularly. Which we actually already found those probabilities in A, B, and C. So looking at our female, we have our 278 females out of the 600. Plus, we have 300 out of the 600 that eat breakfast regularly. And then we have our overlapping piece. So remember, we have everyone that eats breakfast regularly, the females. Notice how we double counted those females in both of those categories. So we need to make sure that we at least subtract out 110 of them because they're double counted in here. So I'm going to make sure we subtract out that 600, and we're going to get 468 people out of the 600 that are female or eat breakfast. And we get 0.78. So the largest takeaway and the biggest takeaway from this entire activity or entire notes is this: and versus or. When we're looking at and, we're looking at the events occurring together. When we're looking at or, we're looking at either or occurring. So either being a female or eating breakfast, and then making sure that they're mutually exclusive or not. Remember, mutually exclusive. If they are mutually exclusive, that means that they have no events in common, so no overlap. If they are mutually exclusive, not mutually exclusive, just messed that up. So if they're not mutually exclusive, they have some overlap. Or no, we have no events in common, so no overlap. And then when we are mutually exclusive, that they have no overlapping pieces. So when you're looking at your worksheet here, you have some decks of cards of the first piece that you're going to be looking at. And then it says just seeing if they're mutually exclusive or not and explaining. So if they are or are not, and then give me an example if they are not mutually exclusive, meaning that they have that overlap. Okay? And we also have, then we're finding the probabilities. So here you'll find the probabilities of our or. We have a 6-sided dice. Finding factors of 12 or factors of 9. Remember, factors are like numbers that are evenly divide 12 and 9. So like 2 and 6 or 3. And then you also have to fill in a two-way table and then find those probabilities as well. Alrighty, and that's it for the notes. Have a great day.